Hi friends, today we are going to learn about the development of use case diagram with the help of rational rows. First thing is that we should know what is rational rows. Rational row is a product of IBM. It is a case tool for the development of the software engineering. For the development of the software engineering. Next thing, for starting this tutorial, we are assuming that students are knowing about the unified modeling language, that is UML tool. For this purpose, you can study a book on UML. You can get a training on UML. If it is not that, don't worry. From this tutorial, we will start from the scratch. Next thing is that we should know the paradigm of the object-oriented software engineering. Okay, because rational rows is dealing with the object-oriented paradigm. For the procedural programming approach, it cannot follow because it is not including DFD and other things regarding the procedural programming. It is having the paradigm for the object-oriented development. Okay. Next thing is that we should know what is ROS. ROS is actually rational object-oriented software engineering. It is a visual modeling tool, and in the rational rows we are having actually three things. One is called as model, second is called as view, and third thing is called as diagram. Models are actually complete representation of the system, and views allows us for the different stakeholders to see the system from their own perspective. Generally, views are having four categories. One is called as use case view, logical view, component view, and deployment view. Each view is having its own diagram for representing the view of the customer and stakeholders. For this purpose, for starting the tutorial, we should know the use case diagram. Before starting the use case diagram, we should know the little bit about the outline graphical user interface of the system. In this one, if you will see, this is called as a standard toolbar. They are always present in every kind of the rational rows software. This we are not going to learn about this thing. So before, when you are starting the rational row, just cancel this one. Next thing is this is called as a browser window. In this one, all our design is present. Whatever the design we are going to develop, it is present here. This is called as diagram window. This portion where the cursor of the mouse is there, this portion is called as toolbox, okay, or toolbar. Suppose that we have selected in this time class diagram, so all the possible components we are going to use for designing the class diagram, they are available here. This portion where the cursor of mouse is there, it is called as documentation window, and this portion is called as log window. Okay, whatever you are doing, it will come here. Next thing is that we will prepare the diagram in this window, okay, and we will save them. Suppose that now we are going to start for the development of a simple use case diagram. Use case diagram, actually we are calling it is a system interaction with the outside world. Use cases, this is a top view of the system with the outside world. Suppose that this diagram we are going to develop, it is the simplest diagram for the student registration system. In this one, we are having two use cases, register and login. This use case, check register. Suppose that one student want to log in on the system, so this use case is telling that before login to the system, we need to check that a student has registered before or not. This is also the actor database. Okay, this is also the outside of the system. This portion of the system, we are saying that this portion of the system, we are saying that this is our system which we are going to develop, and the rest portion, this one is student, local student, international student, they are the actors. Database is also actor because this is also outside of the system, but in this one, this is we are going to store only the data regarding the system. This is local student, international student, and student is a parent class. They are the inheritance class, local student and international student. This is related to the object oriented paradigm. We are saying that all the properties of the students are inherited to the local student as well as to the international student, and they are having some different attributes and features to each other. Now we will start for development of this design. This is the simplest use case. In the use case we are having two things we should remember: actor and use case. This is the top view of the system, how our system will interact with the outside world. Now for this purpose we will start from here. Now go to the use case view. Okay. When at this place, use case view, right click, you will get this specification. Go to the new, here select the use case diagram. This is the new diagram. Generally we are not making the diagram on the main because we will use the system in future. Suppose that for this one we are going to give the name of this diagram student, or you can give you the name as per your convenience. This is the student. We are going to make the use case diagram, but till now because here this is the class diagram window is representing, so all the diagrams are related to the class. But how to get the diagrams here? Just double click here, you will get the diagrams related to the use case. Okay. You can minimize the window from here, or you can increase or decrease the window as per your requirement. This is our diagram window. Now we will prepare the diagram here. What we need to do? First we need to copy the first actor use case from the diagram to here. Just click on the screen on the tool and click on the screen. It will come here. If you are not able to understand what is the diagram, just put your cursor on the diagram. It will pop up the message that what is this diagram. Now this is new use case. We want to give the name register. This is use case register. Second use case we are having the same way, login. Again give the name here, login. Third use case, that is dependent, login is dependent to the third use case. We are calling it check register. That we need to, before login, we need to check that this student is registered to the system or not. Next thing is that if you want to go for the some specification, suppose that you want to give the detail for this use case, go to the open specification, right click on the use case, it will come to the open specification. Here you are having the documentation. What is the objective of this documentation? Suppose that in future, in place of you, if another user is coming for the development of this software, so that he should be able to understand what is this use case, what is the purpose of this use case. So, and in the final it can generate the report also. When our software is complete, design is complete, it will generate the report automatically. So no need for the documentation after that. So for that purpose we can give the documentation for the use cases here. If you want to give, you can provide. For this tutorial we are avoiding this documentation. Suppose that for one example I want to give the detail. You can say that this is a use case about the registration of the new student. Okay, this documentation you can give, or just apply and okay. If you will see, if you are clicking here, the documentation is coming to the documentation window. Okay, when you will generate the final report, it will automatically come. So this is for your future sake only. Now we are not bothering about the documentation for other use cases. Now we are going for the actor. This is the diagram which is regarding the actor. Just click on this diagram and again click to the diagram window. This is actually class actor. Mostly they are the classes. So in the classes we are having the attributes and functions, or their features and functions, or another way we are saying that data and function. So here we are writing the name of the class student. This is the student class. This time we are not giving anything because we will learn in the class diagram to provide the attributes and functions of the student. Okay. Next we are having again two more diagram. One we are calling it international student. Second is class of the student, we are calling it local student. These two are the inherited class of the student. Now we are having another actor, remaining actor from our diagram, which is called as database. If you will see, the diagram for the actor database is looking like this one. So don't worry, we will do. Okay. So name this diagram, go to the specification. You can write the name from here only. We are going to write database. Okay, now this is the actor database, but we are knowing that this actor database, exactly this is outside of the system, but this is static. It is not having any special attribute and other thing. This is physical database. So we should differentiate the active actor to the static actor. This actor is not doing anything. So for this purpose, again go to the right click to the actor database. Now go to the option. In the option menu, now go to the suppress attribute. Okay, what is the meaning of suppress attribute? Its meaning is that we are suppressing the attributes of this class. Okay, this is not this class is not having any attribute. Now again go to the option, again go to the suppress operation. Okay, so in this class the message will be passed at the background that this class is not having any attributes and there is no functions or operations are related to this class. So we are saying that this is a static class, or this is just simply a physical database. Now to differentiate from the visualization from the active actor to the static actor, again go to the option, go here stereotype display. Here you can give some decoration, label. Okay, if you want to give none, it will come none. Okay, suppose that we are giving it label, it will look like this one. Next, in different way, if you want to show none, it will nothing. Okay, it is not saying this is actor. If you want to make this one, you can make in this way. Suppose that stereotype display, we are saying that decoration. Okay, so it will look like this one, that this is a database. So in our diagram it is present in the form of the label, so we are using in this way that this is actor database. Okay, we are saying that this is a class, but this is not having any attribute, this is not having any operation. So you can say that this is a class which is not having an attribute and any other thing. This is only for the representation. This is a physical database. Up to this point we have finished all the actors, use cases and physical database. Now we need to relate our use case, and with the we can create a relation between use cases and actor. So for this purpose, student is passing message data to the register. So for this purpose we are having unidirectional association. Just click on the unidirectional association, click from here and drag up to this point. So this is unidirectional association. It should be clear. We are having three different type of the arrows. One is unidirectional association, second is dependency. Suppose that something is depend upon someone, we need this one. Third one is generalization. Generalization we are using when you are making something generalized, or inheritance you can say that. Next, again data is going from register to the physical database. Next, second time we are saying that student is using the login use case, and now this is the time login is depend upon the check register. Before login we should check that this student is available in the database or not. So for that purpose we will not use the unidirectional association, we will use the dependency. We are telling the system that this use case is depend upon this use case. Now check register, it is again unidirectional. Click on this one and drag up to the vector database. So our diagram is almost finished. It is saying that for specification include and exclude, extend, what we need to do, we are telling that login include check register, login use case include check register. So for this purpose, on this arrow just right click, go to the open specification. Okay. Here in the open specification, click on the stereotype. We are having the drive, that this attribute is drive, extend also, but for this diagram we are going to use include. Apply on this one. Okay. This include is telling that login include the check register. Again, up to this point it's finished. Now the remaining portion is local student and international student. They are not having any association. We cannot connect them directly to the registration because they are the inherited class. So we will use the association generalization. Click here, drag up to here, click here, drag up to here. Okay. Suppose that if you are going to do some mistake, this is when I am removing student to the international student. Okay, we are making that student is a inherited class of international student. So what you will get the message, you will get that this is an invalid circular inheritance or realization combination. So it will give you error. So this tool will help you if you are not having the idea about the object oriented paradigm. We should know actually when you are preparing. Okay. So this is our use case diagram. The simplest use case diagram is ready. This diagram is about the student registration system. Student is registering, registrar is sending the data to the database. Student is login, login include the check register is checking the validity to the database. International student, local student, they are the generalization of student or inherited class of the student. Okay, we should know what is inheritance and what is generalization, all the technical definitions of the diagram or object oriented paradigm. Now our diagram is ready. Next, one thing we can do, if you want to check that your diagram is correct, For that purpose, go to the report. Okay. When your diagram is finished, and if you are not assured that some associations are correct or they are incorrect, you are not assured, in that case, go to the report, come to the access violation, click on this one. If there is any access violation, it will display you, otherwise it will give you the message there is no access violation found. So this diagram is ready. You can save the diagram. Other diagrams you can also make in this one. Okay. In the next lecture we will discuss about the next diagram for the use case only. Okay, thank you for watching this video. Please subscribe to my videos for other rational rules tutorials.